So we're going to start off with here in chapter 18, numbers 57. Number 57 talks about, we start off with two identical charges that are 0.5 meters away. They give us this information. And we want to find the location of this third charge so that the electric field ends up doubling. So now, right now we have these two charges and there's some kind of third charge some x distance away. And right now, looking at this one charge in red, this one charge in red is going to create an electric field pointing this way. Now I assumed that this 2q charge is going to be to the right. The reason I put it to the right is because if it is to the right of this green charge, it is going to create an electric field in the same direction as the red charge, meaning now it can be doubled, which is what the question is asking for. Where is the location of the 2q charge so the electric field will be doubled? Based on my drawing, I can try to solve it. So what I do know about E1 and E2 is that in order for them to be doubled, E1 has to equal E2, and they have to be pointing in the same direction. So I start off my equation like that. So I find the absolute values of E1 and E2. So I use that whole KQ over R squared equation. So I start off with K plus 1Q for the red charge divided by 0.5 squared, because that's the distance between them. And for E2, I do K squared, times 2Q divided by X squared. I used X because I have no idea what the distance is. And I know what K is, but I left it as K because I know I'm going to eliminate them. And technically the Q is a charge being multiplied. I don't know what that charge is, but since we have Q on both sides, I can eliminate that too. So I end up with 2 over X squared equals 1 over 0.5 squared. From there, I can just, cross multiply. 2 times 0.5 squared equals x squared. And I solve through this. I square root everything, and I get two possible answers. I get x is equal to plus or minus the square root of 2. So in reality, there's two possible answers. Either my answer is 0.71 or negative 0.71. Now, there's only one correct answer. Both these answers represent a situation where E1 equals E2. The only difference is one of them is going to be pointing in the same direction, both electric fields, and one of them is going to be pointing in the opposite direction. Now the correct answer is 0.71. So there might be a charge over here, there might be a charge to the right, and the electric field pointing this way. If the charge had been to the left of the plus Q, the electric field would be pointing the other way, which is wrong. So to better represent this is like, I know the answer is 0.71, but we're going to redraw this to look at the whole situation. So here we go again. So here's our charges, and 0.5 meters away. Now, since my answer is 0.7, I actually technically drew the first one wrong. If the charge had been 0.71 meters away, either to the right or to the left, representing our two answers, our charges are either going to be here, we'll call this option 1, or it's going to be here, we're going to call this option 2. Again, I know the answer is option 1. If we look, the reason for this is because if we look at option 2, this red charge, again, is going to put an electric field pointing this way. This option 2 charge is going to make an electric field pointing in the other way. That's not possible for our answer because we're trying to find a way to double the electric field. If we have the same magnitude but pointing in opposite directions, they're not going to double, they're going to end up canceling each other out. Option 2 is wrong. So if we look at option 1, if we look at the option 1, again the red charge is going to create an electric field pointing to the left of this green plus Q charge. And the option 1 charge will also create an electric field pointing in the same direction. Meaning now we have the potential to double because they have the same magnitude. So our answer is the 0.71 to the right, not the 0.71 to the left.